Now we go on. It's AI, Russia. We speak about artificial intelligence and the recent developments and what happens in our country. But what happens? Science and scientists are getting younger and younger. It's not just a fashion, it's a logical development, logical evolution of society where intelligence does not correlate with age necessarily. We have Petr Vol'nov, student from ITMO University from St. Petersburg. He has a very interesting topic to cover. Sports AI. Why should we stop using our personal coach? Petr, you have the floor. Hi everyone, I will speak about a very interesting topic, proctoring the performance of home training. How we found this problem, what were the problems, and how we solved it. I think it will be very interesting to listen to. Data and the task. COVID-19 broke out, many lessons moved distantly. We have PE or physical exercise in school. You cannot do them online. People have injuries. In general, physical activity dropped. Teachers cannot have normal lessons. So the question is what to do. We had to analyze it for proctoring, trainings, but not only recognizing the images or videos, we have quite a lot of hidden problems, like people try to cheat or do not a very good job. Maybe the technique is poor. You all have to take into account in order to give a fair assessment. This is what we did during the last 6 months, and I think we did a good job. These are the input data from the lessons where school children and students sent the videos of their training. First, the main problems, which might not be that obvious when we speak about proctoring of exercises. First, one exercise can have different forms. When you squat, you can have arms at your body, you can hold them sideways or up front, but it's still the same exercise, even though the form and shape is different. You can turn to the camera at a different angle, you can turn sideways, and this is a big problem. Second problem is when we detect upper or bottom poses, it's really hard to see if the chest of the person touches the floor or not when they do a push-up. So we needed to analyze the higher pose and lower pose and analyze the amplitude. Next problem is we do not have a data set of ideal performance. We only get the data from our users, and they have a lot of imperfect chin-ups and push-ups, squats, and so on. A lot of imperfect exercises. The problem is we have different angles, vertical videos, horizontal videos, somebody takes from afar, somebody is up close, somebody does just a poor job, and we have to remark the video. I would like to speak about how we solved the problem. So this is the plan. First, we needed to... So what we had to do, we detect the person, we highlight key points, we have quite a lot of good working models, then we use these points and we break down the sequence into frames where we have only one exercise. Then we use calculation model for squats, for specifically that exercise, to single out the number of repetitions. Then we analyze and set the peaks, the top peak and lower peak. We can avoid cheating or poor execution, and we can provide some recommendations on what to improve, which is great, and users can not only just get true false, but also understand the problem at the bottom and do the exercise better next time. Now I would like to speak about the technologies, how we solved it.
There are a lot of publicly available approaches, and they are split into three groups. OpenPOS, CanGPU, they are heavy-weighted, but the server is needed to run on. Out of the advantages, they are suitable for groups. You can get group training, but they need to sell frames to the servers, and the connection is down, so it would be difficult to make. It will a big load on servers. Next is the media pipe. It's from Google MailKit. It works on CPU and is strongly optimized for mobile devices. Only first frames goes, then the track. And you can add more exercises there which are different from the position. If in one point the position is same, but you can make the difference by different exercises. This is good from a practical point of view, but on mobile devices it works on CPU. CPU on mobile devices are only top models. It means that very high overheat of the device itself, and OLED screen can be overheated. If we get this coordinate and Z coordinate, the model works only for one user, no group training is possible. And third group are professional models, Apple ML kits, and they are used directly on the library. This approach uses the internal CPU. The problem is with data, because there are no available public model. You cannot try it. It's just a closed box, and it's very hard to retrieve data from it. We use different approaches for different interfaces, different applications. I'll tell you a little bit later about it. Next step is classification of exercises, which we get for personal models and for the global model, where we provided from framing. Key and cat boost to classify exercises. It's quite suitable, very fast to be trained. Just one exercise can be shooted from 5 points, and that's it. Frame different, but it's absolutely not suitable for variations when hands are in different places. It makes focuses on non-key moments inside the exercise sometimes, and if there's a big number of data sets, different exercises, there are a lot of overlaps. When the person changes the posture, a lot of false work, and sometimes the low quality of execution can be detected as another exercise. It's not detected. It's good for detects or trials. Linear LL, main pitches, and as an output we have a mask predict and mask. It works well, quite fast. A bigger data set is needed, but it allows to avoid some problems with the border conditions with unprecise execution. It can be learned easily on a big amount of exercises. Up to 30 exercises can be easily downloaded there. Timestorm, as it's a very modern approach. I don't have time, unfortunately, to discuss it in detail, but this is the set of frameworks. It's a good model which works with the GPU and needs to be learned, but as a result, the precision of business metrics was 100%, and this is the best approach which we tried. But unfortunately, it cannot be normally put into the device, especially weaker devices. Sliced video, we just found main transitions from between exercises, between peaks, and then we clean it up and split it by 30 classes grid, using and capturing all main transition points. That's what it looks like. You can see on this video, on this demo. Counting exercise repetitions. The story was that we should not only count, but find some peaks, and on old classifiers it worked poorly because the peak was not close to the up. In case of push-ups, up to 70% of repetitions gave a lot of opportunities for falsifying. When we started to add the top point, the quality of exercises was used by the gradient, not all for 30 classes, but on one. We got a very good result, give or take one fraction of second at the top or bottom part for fast exercises. Next task is the quality for upper and lower point and recommendations. Here we use different approaches on recommendations and make predicted for each group of points. When due to small data set, it is difficult to learn and to train based recommendations. So we trained several simple models for hands, for legs and feet, and we gave some angles. On the set of exercises, it allows to understand by knowing what should be the exercise. If there's a mistake on one hand, we can understand what is wrong and look at key angles, what are the differences, and then give the recommendation to increase the angle by 180 degrees, and we understand what happens, increase elbow bend angle to 180, we allow this to give recommendations. As a result, we have working 27 exercises at the required speed of 15 FPS, give or take 30 degrees, camera position experimentally to split the best class transformer in 100% of cases. We detect very good repetition accuracy, and to classify and for their peaks, linear approach worked best. On top of that, we created Telegram bot to check for pulses and to get some feedback, make some distant exercises, and it is very good for teachers. Now this system works at ITMO in a pilot mode in the physical and technical lyceum for distant trainings and workouts, and distantly the number of students just exclude. Physical culture now it's compulsory with the minimum factoring, and teachers use the tags and make special programs and curriculums for pupils and students in different weight categories, different gender groups in universities and schools. Approximately, you can see how it works on this example, on the example of this application. This is quite a basic program. Please see the example of its execution. And next comes the video player where you can see it. There are audio prompts. You can't see them, unfortunately, but what should be done, you can see. Generally speaking, you can train, you can have the exercises in a distant format. That's it about the main approach. We managed to solve all the tasks. We managed to make it on the devices with minimum latency, minimum load for servers. In future, we hope that this system can be used in other schools and universities for online trainings and make the life in the remote mode more active. If you have any questions, please write me. I have the contact details on my pages. I hope it was exciting. If you try to use same results, you can use same approaches. Thank you, Petr, for a very exciting presentation, which made many people think. At least it was important for me.